Hello. In this lesson, we're going to review solving systems of equations by substitution. Now, you had this in Algebra 1, so this should just be a quick review. I will tell you when to pause and take notes. Now, we're going to jump right in with an example. We have here two equations. They're both linear, and this technique is called substitution because we're going to substitute the solution to one variable into the other equation. So let's jump right into our example. We need to solve one equation for x or y. In this example, the first equation is already solved for y, so we don't have anything to do here. But we are going to use that information, the fact that y is equal to negative 3x plus 5, to help us solve this system of equations. We're going to take the value for y, negative 3x plus 5, and substitute it in the second equation every single place we see y, like this. When we do that, we get rid of y as a variable, and now we only have x as a variable, and we can solve for x under these circumstances. So let's do that here. Pause now and copy down everything you see on this slide. X turns out is 1. Now we're going to use that information to find out what y is by using the value of x is equal to 1 and substituting it back into the original equation and solving for y, where we find out that y is equal to 2. So our solution is the coordinate x equal 1, y is equal to 2. Now it's very important that we name our solution. This is the point of intersection. If I were to put both of these equations into slope-intercept form and graph them, they would intersect at the point 1, 2. It's also very important to check your solution. We make lots and lots of silly mistakes. You've seen me make them on the board already. So plug your ordered pair back into the original equations, not any that you have manipulated, and make sure that they make both equations true. In this case, they do make both equations true. So pause now and copy down everything you see on this slide. Now let's go through a second example. In this case, we have two equations. Neither one is in slope-intercept form, and so we have to solve one equation for x or y. I have chosen to solve the first equation for x by subtracting 3y from both sides, and now I have x is equal to negative 3y plus 2. Pause now and copy everything you see on this slide. Now I'm going to use the fact that x is equal to negative 3y plus 2 to substitute that value in the second equation every place I see x. And so I have now, instead of 5 times x, I have 5 times negative 3y plus 2. Now that gets me down from 2 variables, which I can't solve in a single equation, to one variable, which I can solve in a single equation. So now I'm going to use the distributive property, I'm going to combine like terms, and I'm going to solve for y. It turns out that y is equal to 1/2. Now that I have a value for y, I can use this value of 1/2 to go back and find a value for x. But before I do that, please pause now and copy everything on this slide. Now I know that y is equal to 1/2. I'm going to take that and substitute it in for y in the original equation and find the value of x. And it turns out that x is also equal to 1/2. And so my solution is x equal 1/2, y equal 1/2. Now that's just a coincidence. It doesn't normally turn out that way. Now, our point of intersection is 1/2, 1/2. It is very important to check your solution. And so you do want to go ahead and plug in the ordered pair in both of the original equations and make sure that both equations are true. And in this case, if we check them, we find out that both equations are true. Now, that's the end of my part of this short video. Now it's your turn to find the solution to the following systems of equations using substitution. And to help you along, I'll give you an answer key. Those are the solutions. Come to class with your best attempt at solving both of these systems of equations. Bye.